Good morning, Doctor and all my friends. We are from the MedTech team and today we will present an overview of our system documentation for the Digital Mental Health Literacy Hub. This documentation defines the foundation of our agile-based development and stakeholder collaboration. This documentation outlines all validated system requirements to serve as a shared reference for developers, testers, counselors, and academic advisors. It ensures alignment between technical development and user needs, supporting the goal of improving mental health literacy through digital tools. The platform enables university students to manage mental health using interactive modules, mood tracking, AI recommendation, telehealth booking, and peer forums. It supports role-based access for students, counselors, faculty, and administrators while ensuring compliance with GDPR, HIPAA, and FERPA. Key terms include AI, PWA, RESTful API, SRS, and SD. This document is guided by Software Engineering Center and reference from the creativity and visual paradigm for UML diagramming technique. The document details both functional and non-functional requirements using use cases, domain model, activity, and sequence diagram structure to support agile development practice.
In this session, we will present our user persona and relate user story for the digital mental health literacy's help. This person helps us to ensure the system features are proposed built to meet the unique needs of each stakeholder. First is student. Students need private, engaging, and easy to use mental health tools. Their key story including completing interactive module to view emotional awareness. Next, using AI mood checkings for self-reflection, engaging in anonymous peer support forums, scheduling online counseling sections. Mental health professional. University counselor need tools for proactive supports. Their key story including accessing real-time mode data to identify at-risk students, conducting secure video counseling sections. 3 is faculty members. Their story including completing scenario-based training to recognize distress, submitting anonymous alert for professional follow-ups. 4 is administrator. Their key story including using dashboard to monitor user trends, leveraging predictive tool for planning and staffing. This insight support data-driven decision at the institutional level. Therefore, personal student, counselor, faculty, and administrator from the foundation of our system design, their defined and user story guide every place agile development, ensuring a user-central approach.
Use case diagram. This use case diagram illustrates the core functionalities and the categories into 6 functional modules based on user roles, which is user module, emotion record and tracking mode, counseling module, faculty module, counselor module, and admin module. Which function is student can log in, access learning modules, track mode, get AI recommendation, book telehealth sessions, and join the peer forums. For the counselors, they are managed session and prescribe digital treatments. Next is faculty. They are alert counseling teams and complete the training. And the administrators are view the system analytics and manage the access. Next.
Now I would like to explain about the class diagram. Class diagram is a model that the keys and entities and how they relate to each other. At the top, we have a general user class, and that's the super class for 4 roles, which is student, counselor, faculty, and administrator. Next, the student can create multiple mood records and can participate in forums, and each forum contains many forum posts, and each post is linked back to its author. After that, student and counselor are linked through the appointment class. Then a counselor can manage many appointments at the same time. After a session, a counselor can prescribe digital resource to students. This is represented by the digital prescription class. And then faculty members can submit alerts about students showing signs of distress. Faculty can also complete training modules, which include content and certification status. Administrator access analytics dashboard to monitor system-wide data, filters, and usage trends. After that, in the class diagram represent the data structure of our system and supports all use cases from login to analytics. It ensures clarity, consistency, and efficient system design.
Next, step diagram. This diagram illustrates the different steps and transition of a telehealth appointment in the system. First, the appointment starts in the new step after being created. Then the appointment is assigned a time slot. Then when the appointment is confirmed, both counselor and student confirm the sessions. Next to the in progress, the sessions begins. When the sessions is complete, the session ends successfully. If the appointment is cancelled, user may cancel before the sessions. If a user does not join within the allowed time, it marked as no-show. Final step for all complete, cancel or not show.
We will now present the launch praise, which outline the sprint structure and the products backlog of our agile development plan for the digital mental health literacy hub. In Sprint 1, we focus on the cross-system setup and student-facing module. We interpret first is central login, which is UC001. Second is interactive learning modules, which is UC002. And the animals peer support forums, which is UC005. This sprint was led by Etienne and supported by 1 Sprint 2 handle AI interactions and mood analysis factors. This include the AI power mood tracker, which is UC003, smart content suggestions, which is UC006, assigned to YING, which specialize in AI functionality. For Sprint 3, it was deliver our counseling and dispatches modules, specifically telehealth sections booking, which is UC004, and digital therapy prescriptions UC009. This sprint was a joint effort by Warner and Ling. Next. For Sprint 4, we decided Sprint 4 to faculty interactions and student safety. First is animals alert submissions, which is UC007, interactive mental health training for faculty, which is UC010, handled by Ning and focus on UX and behaviors for Sprint 5, it assess the administrative layer, the analysis dashboard, which provide insight into system direct trends and mental health engagement. It was comparative sprint conducted by all team members. Last, Sprint 6 focus on quality assurance. We conduct interaction testing, resolve bugs, and validate system performance. We also prepare a deliver final stakeholder demo. All the members participated to ensure that the system was launch ready.
Next is user stories. Each user story follows the Agile format and maps to a specific use case, which is from UC001 to UC010. It includes the actor flows of events, conditions, and exceptions, which is supported by the activity and sequence diagrams to visualize the user journey and system behavior. For the first user story, which is login, the user goes to the login page, enters their username and password. Then the system will check the login using a secure method. If it's correct, the user is taken to their own dashboard based on their role. For the alternative flow, if the user forgets the password, they can click on Forgot Password to receive a recovery link via the email. Next. The second user story is assessing learning modules. Flow of this event is the students log in and opens the module sections. They choose a topic like anxiety or coping, then go through to the content such as quizzes or the videos, and the system will save their progress and give the badges. For the alternative flow, if a student lives in the middle of a module, their progress is saved and then they will continue when they are next time logged in. Next.
Now I would like to present the third user story, which is track mode. And the actor for this user story is student. Main goal is to submit and track mode with AI analysis. Precondition is student is logged in. Post condition is mood entry, store, and visualize. And as a student, I want to log my mood using text or voice so that I can monitor my emotional patterns. And the flows of this event, which is student access mood tracker, and then submits input, and system analyze entries via AI. Lastly, mood trend is updated on the dashboard. And there's two alternative flow. If the student choose voice input, the system convert speech to text before sentiment analysis. And the other alternative flow is if the student declines to submit, the system offer a reminder option for later in the days. And the exception for this user story is if input is not recognized prompt for retry. Next. And the fourth user story is book telehealth session. And the actor for this user story is student main goal is schedule a remote session with counselor. Precondition is no conflicting bookings. Post condition is appointment confirmed and scheduled. As a student, I want to book an online session with a counselor so that I can get professional mental health problem. And the flow is student open the scheduler and then choose time slot and counselor confirm booking and appointment is added to the calendar. And there's two alternative flow in this user case, which is if the selected counselor is unavailable, the system suggests the next available counselor or waitlist enrollment. If the student already has an appointment schedule, the system asks if they want to cancel or reschedule. And there's an exception for which is if no slots are available, show a waitlist message. That's all for me.
Next, the fifth user story, which is joint peer forum. The actor for this story is student, and the main goal is post anonymously in peer discussion forum, and the precondition is student is logged in, and the post condition is post is published or moderated. And the description of the user story is as a student, I want to share anonymously in a peer support forum so that I can express and connect with others safely. And the flow of events of this user story is the first one is students select a forum category, the second is post content anonymously, and the third is AI or human moderators review the post, and the last one is post appears in the thread. And the alternative flow one is if the post contains sensitive words, the system delays publication until human moderation is complete. And the alternative flow two is if a student flags a post, it is hidden pending review. And the extension flow for this user story is if a post violates rules, it is flagged. And the sixth user story, which is receive AI recommendation. The actor is student and the main goal is get AI generated mental health resource, and precondition is track mood or complete modules, and the post condition is personalized suggestion display. The description user story for this user story is as a student I want to receive personalized resource source suggestions so that I can improve my coping strategies. And the flow of event for this user story is system evaluates recent activity, then matches strength with recommendation rules, and the last is suggestion appear on the dashboard. The alternative flow one is if a student marked as recommendation as not helpful, the AI excludes similar suggestions in the future. And the alternative flow two is if the user has not interacted with the system for 7+ days, the AI shift to suggest motivational content. And the extension flow for this user story is if data is insufficient, prompt for more usage.
For this user story is alert counseling team. The actor is faculty. The main goal is submit students distress alert. For the precondition is faculty is login. For the post conditions is alert is security log and returns. Next. For this user story is view analysis dashboard. The actor is administrator. The main goal is view and export system usage statistics. Precondition is MA is login. For the post conditions is analysis displays of exported. Next. This user story is prescribed digitally. The actor is counselor. Main goals is assign recovery resource after the sessions. Precondition is counselor is login. For the post condition is student receive prescribed content. And the last is user story is complete faculty training. The actor is faculty. Main goal is complete mental health training modules. Precondition is faculty is login. For the post condition is training marks complete. Certificates granted. Thank you. That's all.
For the performance and other requirements, for these performance requirements, which is the system must respond in minimum 2 seconds for user action under normal network. Second one is throughput. There are support more than 100 concurrent users. The capacity is up to 10,000 users. The scalable by 20% yearly. The availability is 99.5% uptime and the off-peak maintenance. The software system attributes its usability is easy to use and reliability is stable performance with fast recovery. The portability is mobile and the desktop, for example, is like Chrome, Edge, and Firefox. For the safety features is escalation system for risky user content, and the environmental is cloud-based and energy efficiency hosting. Next.
Now I would like to present the design constraint of the digital mental health literacy hub. First, environmental constraint. The system must operate in a wide variety of student environments, support multiple screen size, and perform well on mobile devices. Second one, hardware constraint. Clients must have at least 2 GB of RAM and run modern HTML5 compatible browsers. On the backend, the system must run on cloud infrastructure to ensure scalability and high availability. Next, security constraint. All login are secure using SSO via institutional identity system. All sensitive data is stored with AES 256 encryption. Additionally, post and mood entries are scanned in real time for harmful expression. And for the compatibility constraint, the system must seamlessly integrate with university infrastructure like the SIS, LMS, and counseling schedulers. The interface must work with Chrome, Firefox, Edge, and Safari on the mobile. And the last one is performance constraint. The system must support at least 100 concurrent users, especially during exam stress period. Our AI engine must deliver recommendation within 1.5 seconds, even under peak demand. In conclusion, this constraint ensure our system is robust, compliant, and scalable. That's all from us. Thank you.